Hey everybody, thanks for clicking on this video. Today we're going to be working with converting polar coordinates into rectangular coordinates. Don't forget to hit that subscribe button so you can stay up to date on all the videos we have coming out from the channel. If you want to follow along, the links to the companion worksheet, they're in the description below. So what we're given a point in polar. And so the first thing we want to do is we want to graph it. So we first draw our Cartesian axes, x and y, and then we want to say, all right, it's 4 units away at an angle of 3 pi over 2. So 3 pi over 2, where's that? Well, this is pi over 2, this is pi, so 3 pi over 2 is going to be this way. And then it's 4 units away, so that's 1, 2, 3, 4, right there. Now the question is, if we want it in rectangular, what we want to know is how far to the left or right of the origin is this? Well, for this one, it's not. It's neither to the left nor the right. So that means our x-coordinate is 0. And then we want to know how far above or below the origin it is. Well, this is 4 units below. So that means our rectangular coordinate is 0, negative 4. Now, if you need help drawing these, because all of these we're going to draw them first, I'm going to put a link in the upper right-hand corner showing you the video where we go over how do we draw these, because that's really important to know how to draw them before we convert them. So let's look at the second one. So with the second one, our coordinates are negative 3, comma pi. So drawing our axes, now we say, well, where's pi? Well, pi is right there. But the distance is negative 3. So instead of going 3 units this way along pi, we actually go 3 units in the opposite direction. That is 1, 2, 3, right there. So in rectangular, we ask how many units to the left or right? It's 3 units to the right. How many units up or down from the origin? It's 0. So we have 3, 0 as our rectangular coordinate. Now these first two are a little bit simpler because they ended up being on the x and y axes. And so that means either the x or the y coordinate was 0. Now let's look at one where neither the x nor the y coordinate will be 0. So here we have 6, 150 degrees. So if I draw my axes, 150 is going to be right here. That's 150 degrees. Now that's going to be 30 degrees inside there. That's my reference angle, and we'll talk about that in a second. Now the distance is 6. So 1, 2, 3, 4, 5, 6. That's my distance. Now what we want to figure out is, what are the x and y coordinates? How far over did it move? How far over from the origin? That's x. And how far up from the origin? That's y. Well, what we can think about is, think about this as a right triangle. And since we said that this angle was 30, this makes a special 30, 60, 90 triangle. Okay, so that means this angle up here is 60. And so, based on our rules for a 30, 60, 90 triangle, the hypotenuse is twice as long as the side that's opposite 30 degrees. So that means this side right here has to have a value of 3. And this side down here, you just take the short side and multiply by square root of 3. So it's 3 square root of 3. So for our coordinates then, we are this many units to the left of the origin. That's how far to the left we go. So this is negative 3 square root of 3 for the x value, and we go this many units up. So that means it's negative 3 square root of 3, 3 in rectangular. So looking at the next one, here we've got negative 2, negative 5 pi over 6. Now if an angle's negative, that just means it rotates in the opposite direction. And so 5 pi over 6 is what we just saw. That's the same as 150. And so we would rotate this way. But negative 5 pi over 6 means we rotate the opposite direction. So that means it's right here. However, our distance is -2, so we're not going to measure 2 units this way. We're actually going to go the opposite way and measure 2 units this way. 1, 2, like that. So this is -5 pi over 6. And this angle right here is pi over 6. And so this is our distance of 2. But pi over 6, well, that's just 30 degrees again. And so what we have is we have another 30, 60, 90 right triangle. So our distance up and down is 1. And our distance along the x-axis is square root of 3. So our coordinate then is square root of 3, comma, 1. Now for number 5, here we've got -5, comma, -90. So positive 90 degrees is up here, but negative 90 degrees is down here. But instead of going 5 units this way, we're going to be going 5 units in the opposite direction. So I'm going to measure out 1, 2, 3, 4, 5, right there. And this one actually turns out to be on the y-axis again. So that means that we're dealing with a value that is 0 units to the left or right, but it's 5 units up. All right. Now this last one is really vague because it doesn't give us an angle and it doesn't give us a distance. So what I'm going to do is I'm just going to draw out this and call this theta, whatever the angle is, and whatever the unit r is, don't know, I'm just going to call it that, r. And so what are we trying to find? Well, we're trying to find my x value, and we're trying to find the y value. The thing is, theta and r, those are known values, but x and y are not. So how do we solve for them? Well, if we want to solve for x, we know theta, we know r, we don't know x, but x is the adjacent side. So if I say cosine of theta equals x over r, if I want to figure out what x is, all I have to do is multiply by r. So r cosine of theta, that equals x. And I can do the same thing for y, because y is opposite the angle. So sine of theta equals y over r. So to get y by itself, I multiply r over to the other side. So we get r sine of theta equals y. Well, this right here, these are exactly the values of x and y that we need. So in rectangular then, the x value is just r times cosine of the angle, and the y value is r times sine of the angle. And so if you go back, you can actually go back to all the previous problems in this set and just take the r value times cosine of the x value, the cosine of the angle, and get the x value, and take r times sine of the angle, and that should give you the y value. So this rule right here works for any set, any polar point, to convert into rectangular. Thanks for watching. If you liked the video, please give it a thumbs up. If you have suggestions or problems you want to see worked out, type a comment below. To support the channel, click the Patreon link to help keep this going. Thanks so much for watching, and remember, the best way to understand something is to do it.